Using changelogs for efficient search and content discovery. I'm going to be glued to this one, Ashley Pittman.
Hello. What I tried to do here was submit the presentation as the bio and the bio as a presentation so that Steve could just read the presentation. I could stand up at the end and tell you who I was, but he wasn't up for that.
We could trade places.
I've got some notes. So using changelogs for efficient search and content discovery. This is a research project that we tried internally. We kind of looked at what Lustre provides with a sort of clean sheet of paper and tried to think of something interesting and different that we could do. And changelogs are a relatively new feature in 2.1. Certainly there weren't a lot of people using it when we started looking at this. It's a very low-level feature. It's great for building things on top of, and this really wouldn't have been possible without changelogs. So that's kind of where we started from. So changelogs, what you get, you enable changelogs on the MDT. You just do that once, and then you go through this cycle. You just repeat steps 2 and 3, where you read the changelog, you consume it, and then you go back and mark it as consumed. And the MDT deletes it. So they're safe to use in that you don't actually mark them as deleted. Reading them and marking them as deleted is different. So you can kind of shut down the consumer and then start it up and not lose data, which is really useful. There's an example of the changelog. If anyone hasn't seen that, this was simply I think copying the Lustre source onto the directory. So you've just got a sequence number. You can see that the make dir, or just what the operation was, timestamp, then the FID, and the file name, which is really just there for convenience. So, if you think about a file, most of the data in a Lustre file system is static for most of the time. Obviously, it's created and it does change occasionally, but particularly with these really large file systems and with HSM, the files aren't dissimilar to an object. Objects are normally considered immutable, but for most files, actually, they don't change. So for most of the lifetime, it's pretty much the same thing. So you can think of a file as an object. It has attributes, and the name and the directory can be perceived as just attributes rather than the POSIX hierarchy. That certainly makes things a lot easier to think about. Why search? Well, why not? This is a research project. So, this is something that actually a friend of mine said to me about kitchen implements. He said, if you can't find it, you may as well not have it. I remember going to visit a friend and they spent half an hour looking for a pineapple corer, and eventually they gave up and just used a knife. So, you can have all these files, but actually, if you have no way of getting to it and no way of locating it, then what good is it to you? File systems getting larger. You can run grep on a Lustre file system now, but with HSM, it's going from incredibly difficult to impossible. So we think it's an interesting thing that has applications. So we don't want to reinvent the wheel here. Just use a standard off-the-shelf sort of a Web 2.0 tool. It's written in Java, which is socially acceptable these days. This is just a quote from Wikipedia. It's a distributed, RESTful, open source search server based on Apache Lucene. It's implemented it's a flat database, schemaless. It's implemented. It has shards and then mirroring, so you can spread the load over many servers and get scalability that way. It's also very resilient. One thing I didn't put here is Elasticsearch is used as the search engine behind Twitter, so very scalable. It's index-based rather than a database, so it's good if you put a lot of data into it and then query it many times. It's not so good with modifying data. I put the Lucene logo in there just because I think it's one of the cooler logos that we have in computing. So Elasticsearch internals, you can have multiple indexes hosted by the same Elasticsearch instance. Typically, you might use multiple indexes. You might map a particular file system onto an index. You can run queries across indexes. You can have multiple types in an index. For this context, we used files as one type, directories as another type, and that was the only two types that we did. And then you can create documents of a type. Documents are schemaless, although it makes most sense if every document of a type has the same schema, because then you can search on the sort of key value pairs in the schema. It's all sort of comes from the Web 2.0 market, so everything is based in JSON. It's all done through HTTP GET and PUT queries. There's another product called FSRiver, or File System River, that sits on top of Elasticsearch. Again, you can just download it. It's a plugin to Elasticsearch. And what FSRiver does is it's a system where it sits on top of a POSIX file system, and you just point at FSRiver. You upload a JSON document describing the file system, the mount point, the scan rate, what files you'd like to index, and that kind of thing. And it goes off and does it all in the background. It's configurable frequency. The one thing that it does which is interesting, is that it uses Apache Tika, which is a way of extracting keywords from what are perceived to be common file types. Certainly doc, HTML, source files, things like that. You can and it can also just work with text files and index the whole contents. I do wonder how many PowerPoint slides and Word documents are saved on Lustre. It's not really its core market, so for searching, data sets, obviously new plugins would have to be implemented, and that was beyond the scope of this. But for simple file types, then you get all this for free just by using FSRiver. Obviously, scanning the Lustre file system at the scales that we work at is something we want to avoid. So we set about changing and modifying FSRiver to consume changelogs rather than to do the scan. This is incredibly easy. Actually, you consume the changelog. You use fid to path. That gives you the file name. You stat the file, and in fact, actually, the FSRiver code stats the file anyway. So this was a surprisingly easy thing to do in the end. It was more about deleting code rather than writing code. And you just change the file system scan to call the changelog read, and then you can increase the frequency of the scan, so you can get it to do it every 2 or 3 seconds. So it allows very real-time indexing of the files, of the file system metadata and the file contents into the Elasticsearch engine. Elastic-specific extensions which were there and would be easy, but we didn't actually implement. But we put the fid in the JSON document. That wasn't so difficult. It would be very, very easy to call LFS get stripe past that and update and extend the JSON document to include the striping information to allow queries by OST location. I know that's an interesting thing for a lot of people. I'm not quite sure why that's there actually. One thing we did look at was integrating this with HSM and actually archiving or scanning files and doing the content search as you copy the data back out to a HSM file store, and sort of integrating Elasticsearch with a policy engine. What we found then is that you can only actually search a file when it's archived, and although you can search, doing a search and getting a subset of results is probably worse than not being able to search at all, because it tells you things that aren't true. So you really need to do this separately from the HSM step, although it's easier to do it with the HSM because of the bandwidth, or because you can, by the time you've read it, you might as well do it. The downsides of using Elasticsearch, well, scalability, Elasticsearch is very, very scalable, but it works well with something like Twitter, where new documents are created and added to. It really doesn't like modifying objects, so it really doesn't like modifying documents. So the performance goes down in that case, which is unfortunate. It's not real time. Changelogs aren't real time either. Elasticsearch imports isn't real time. Actually, you upload a JSON document to Elasticsearch and you can query it, and it actually takes a few seconds for it to be indexed. And so you write something and you try and read it back, and it's not there, which is slightly confusing. But changelogs are asynchronous anyway, so having an asynchronous import doesn't degrade that. You just need to be conscious of that in your workflow. Possible false positives, again, because it's asynchronous, you can delete a file, you can search for it. It can either be still residing in the changelogs or still entering the database. So you can get maybe not false positives, but certainly stale answers to queries. As I say, this will be a great feature to have for HSM, long-term cold storage. For home file systems, it's just going to overload the Elasticsearch of updates. So, unfortunately, not provide much benefit in that case. So, making it usable, we got all this running. It's actually surprisingly easy to do, but what Elasticsearch does is it's purely JSON based. So you make HTTP queries. It gives you JSON documents back. So you can't just give it to users and let them run with it. It's the equivalent of giving somebody root access to the file system. So you need to put a web interface. You need to do all the permissions on top of it. You need the file system walk to actually work out whether a particular user's got access to files, and that's very difficult to do on top of Elasticsearch, unfortunately. All the queries that we've done actually are very simple. They're all in shell, but as I say, to make this into a product, there would be, there's a lot that needs to go on top of it, but the basis is there if you wanted to do that. Conclusions on searching. Elasticsearch is there, FSRiver is there, very, very easy to do. We deleted more code than we added, which was a surprise. The functionality that we got is similar to Robinhood, with the exception of Tika and the document indexing, very much a subset. I say different performance characteristics. We haven't benchmarked either of them at scale. We anticipate, you might look at it and say, well, Elasticsearch scales better than SQL, and you might look at it and say that actually it will be better, but the downside of Elasticsearch is that if you start doing a lot of modifiers, then the modifiers get expensive and the performance actually drops. So it's different rather than better. It really is a flat object-based model. The path walk is really difficult to do from Elasticsearch database. When we needed to do it, we ended up calling the FID to path and path to FID, and actually doing it through Lustre rather than through Elasticsearch, although it would be possible. Again, that's the same as point 4. You can build, or you could in theory build a POSIX-like construct on top of Elasticsearch. It would be very clunky. I think that the Ceph guy stood up here and said, die, POSIX, die. I think there's interesting different ways of looking at data, and POSIX puts some very, very strong restrictions on what you can do. So I kind of agree with that there will be life beyond POSIX one day, and the sooner we get there, the better. And again, the final conclusion, you don't want to be using this kind of thing for short-lived files. You've got the bandwidth of actually reading them and searching them, and also, again, you don't want to be updating things to files that only exist for 5 or 10 minutes. So something like this would be better implemented behind a policy engine rather than alongside one. And that's all I've got. questions.
Questions for Ashley? All right. No? Good? All righty. Ashley Pittman, thank you.